All right, well, welcome back to this new series on building an intertextuality detection algorithm in Python. We're going to be talking today about the first steps in designing this. But before I jump into this, I think it's useful to talk about the Python skill level that I expect that you'll probably need to follow along well. And I'd say that we're not going to be doing anything particularly fancy or complicated in Python, so anybody with a basic familiarity with Python syntax should be able to follow along with no trouble. This is essentially going to be a bit of a combination of live programming and problem solving. But I should say that I have kind of gone through this and planned out what I'm going to do, so I'm not coming into this completely fresh. Now, to get started, it's important to think about how we break problems down in a way that we can use programming to solve them. So our goal here, if you remember, is to build something that takes in a corpus and finds everywhere where documents are copying from each other, okay? We can't just immediately jump to multi-document comparison. We don't even really start with one document against another. We should break it down even smaller than that. So let's really quickly take a look at what the idea here is again, and then we'll talk about what we can do in this episode. So if you recall, if we have text A and text B, and we want to know where text A copies from text B, what I do is I break text A apart into seeds, here 4-character seeds, and I just keep doing this until eventually I find that seed in the other text. I check the minimum length match, check for similarity, and then I start extending until I get beyond the end of the quote, and then I return the quote, okay? So what we're going to be doing today is the very first part of this process. We're going to be getting the seeds from text A and finding where they occur in text B. So I'm going to start with a basic way of doing this, and then I'm going to show you a slightly more advanced way that is a little bit less computationally intensive. In the next episode after this one, we'll get into testing the code and actually profiling it to see which of the methods that we've developed actually runs faster, and then we can pick which one we'll use in our final implementation. Okay? All right, let's go ahead and get started. Here we see just what we have from last time. I've fixed one small typo. I've changed this L to a capital L. That's the only difference you see. Now, to get started, I'm going to create a new file that I'll call intertextfunctions.py, and I'm going to save it inside this intertext folder. I'll save that, and this is where I'm going to put all of the different functions that I'll be calling in the other scripts that we'll use for this tool. So I'm going to add a docstring because I'm going to try to do this roughly how one should when you're programming a module. And I'll just say this contains functions that facilitate detecting intertextuality. Okay, and so this is all I need. I'm going to expand this window very slightly. Our two goals today are to write a function that gets the seeds and a function that finds those seeds in another text. Okay? So all I'm going to do is I'm going to call something getSeeds, and it's going to take a string as an input, and I also want to tell it how long I want those seeds to be. And I'll just call this seed length, and I'm going to give it a default value because I know I don't really want to have to set this every time I run this function. I'm going to make the default 4. You can choose to make it a different length. And then I will go ahead and add some more documentation here. And here I'll say find seeds of seed length in an input string. Okay? And this is going to be very simple. All we're going to do is iterate through the text a chunk at a time and save those results. So I'm going to make myself a list here that's empty where I'm going to put the results in, and then I'm just going to iterate through the length of the text. So for I in range of the length of text, then what I'm going to do is I am going to say seed equals text I to I plus seed length. Okay? Seed length. This isn't going to work exactly how we might want it to because this will continue beyond the end of our string. And I'll show you this really quickly. I'll say print seed. And then I'm going to go ahead and create a main function, or create a function that runs when I call this. So I'll just say if name equals main, then I'm going to run some code. And this just says, you know, if I import this file into other code, don't execute this code. But if I run it from, let's say, the command line, go ahead and do this. Okay, so here I'll just say get seeds, and then we'll just say test string. And I'll go ahead and save this. And if I come over here and I go to my YouTube folder with Intertextuality demo and intertext, and I'll go ahead and run this file, intertext functions, we can see that it says test, est, and so on and so forth. But as we get towards the end, what happens is we see ing, ng, g. We don't really want this behavior because we don't want anything that's not a 4-character seed. So in order to account for this, all I need to do is I just need to say for range in length of text minus seed length. Now if I do this, we're still not quite there. I'll run this again. And we can see that the last seed here is trin. It's missing the very last one. So I'm going to say minus seed length minus 1. And this will then let it act properly. Okay? So instead of printing these seeds, because I don't actually need to do this, I'm just going to append these to this seeds list. So I'll append the seed. Now, I'm not keeping track of where these seeds appear in this input text because actually the index of this list functions as an index for the text as a whole. We're going to approach this a little bit differently here soon, but for the moment, this is how we're going to do it. So now what I can do is I can return seeds, and we have our functioning getSeeds function. I'll print this so we can just take a look really quickly. This will be a list of the seeds. Now we can see we have test, est, st space, t space, st, and so on and so forth. Now that we have a working getSeeds function, let's go ahead and write a function that finds where those seeds appear in a different text. Okay? So this is going to be pretty simple. I'm just going to say def find seeds, and I'll give it a text, and then I'll give it a seed list. Okay? And so what I want this function to do is go through this list of seeds and find where they occur in text B, or any random input text. So find seeds in second text, or let's just say find seeds in text. Okay? So now what I want to do is I want to iterate through all of these seeds and find where they occur. So for seed in seeds, for seeds in seed list, essentially what we'll do is we'll say text.findSeed. Now we do need to keep track of where these seeds occur, so let's create a dictionary that does exactly that. So I'll say seed locations. This is a dictionary. Now what I want to do is we'll find this seed, and I'll say result equals text.find. So then I'll say if result does not equal -1, because remember, when Python doesn't find a substring in a string, it returns -1. I'll say seed locations seed equals result. Okay? And then I'm going to return seed locations. Now, this actually doesn't work how we need it to, because what happens if a seed appears in more than one place in our input string? We need to be able to find that, because right now it's only going to find the very first example of that seed. Okay? So we'll need to write a way to find all the results and a way to save all the results. So what I'm going to do is I am going to change this slightly. So first I'm going to look for a result. That's fine. But then what I'm going to do is I'm going to make this, instead of an if statement, I'll say while result does not equal -1. What I want to do is I want to set this dictionary to save multiple results. So first I need to say something like if seed not in seed locations. So I'll check to see, has this seed been seen already? If it has not been seen, all I'll do is I'll just go ahead and I'll save this in result as a list. And then I'll say else, which means that it's already been seen. I'll say seed locations dot seed append result. Okay? So now I can find multiple results. There are, of course, other ways of doing this. We could use a default dictionary to do this to make sure that if we haven't seen the seed, it'll just create a list for us. We could use set default to do this, or we can even do a try except statement. But for the moment, I'm going to do it like this. So now what we need to do is we need to update result inside this while function. Because remember, the find function in Python for strings only finds the first result, so we need to be a little smart about how we do this. So what I'm going to do is I'm going to say result equals text dot find seed, so it's going to look for the seed, but then I can give it a second parameter that is where in this string to start looking. And this should just be result plus 1, because the last place I found this seed will move 1 over and keep looking for the seed again. Okay? So now, assuming we haven't done anything wrong, this will actually find all of the seeds in a second text. So why don't we go ahead and actually run this and see what happens? So I'm just going to print find seeds, and I'll give it looking for test string. Okay? Then I'll give it get seeds because, and I'll just say test string. I'll run this and we'll go ahead and delete this print statement because I don't really need it because we already saw what that does. And now we'll go ahead and head over to our terminal and run this again. And now we see that it seemingly works. So it finds test at 12, est at 13, st space s, etc., etc. So it seems like it works. Now, let's see if it finds a duplicate result. So what if I add test here? So hopefully, assuming we've done everything properly, it's going to find this second result. And we can find, in fact, it does. Test is at locations 12 and 24. And that seems right? Yep, that seems right. So now we actually have a way of finding seeds in a second text. So we're basically done with what I wanted to do today. The problem here is that in practice, this is going to be quite slow. And in the next episode, we're going to get into actually measuring how slow it is. So I'm going to show you a different approach to this that'll do the same thing, but will operate much more quickly. Okay? So what I'm going to do is I'm going to write an indexing function. So we're going to create an index for our text. So I'll say def get index text, and we'll call this seed length equals 4. Okay? So now what I'm doing is I am creating a new function that will look for my seeds, but it'll keep track of where they appear in my text. Okay? So I'll say creates an index of seeds within an input text. Okay? And there's a reason I'm going to do this, because this is going to make finding seeds in another text go much, much more quickly. Okay? So the first thing I want to do is I want to create an empty index, just like this. Now, again, this could be a default dictionary. We're not going to worry too much about that. But this is going to be a little bit of repetition. We've already seen this, so I'm going to do this fairly quickly. Okay, so this is just copied from the code above. Don't worry, both of these won't end up in our final project, but we're going to go ahead and do this. So now what I want to do is I want to, instead of just saving the seeds, we're creating a dictionary that remembers where the seeds are. So I'll do something like what we saw a second ago. So I'll say if seed is in index, what I want to do is I'll just do index seed append I, else index seed equals I. Okay? And then I'm just going to return my index, right? Now, oops. Now I should, of course, be commenting all of this, so iterate through the text, get seed, add seed to index if we've seen it already, and so on. Now, of course, you'll notice here that I'm saying if seed in index, where I said here if seed not in seed locations. The effective result is exactly the same. So now what's going to happen here is this getIndex is going to create an index of my texts. So what I can do here is I'll just comment this out and I'll say, let's print getIndex, and I will give it a test string, and we can go ahead and just run this. So now what we see is test is at 0, est is at 1, st space s at 2, and so on and so forth. So what I want to do now is I want to take advantage of this new indexing function in finding seeds that appear in a second text. And how do I do that? Well, I can just index both texts and compare the keys in the two dictionaries. And it turns out this is much, much faster than finding things with the find function. So we'll walk through this, don't worry, we'll walk through this fairly slowly and talk about what's going on. So what I'll do is I'm going to write a function called def compare indices. And this is just going to take in an index A and an index B. Now, I need a few pieces of information from this. I need the keys from index A. So we can say index A.keys, and I'll just say, text A seeds, something like this, and text B seeds is index B.keys. So now what I want to do is I want to actually take advantage of these lists of keys. So I'm going to turn these both into sets, like this. So what this does is this creates a set object that contains unique values. And one of the cool functions that comes along with set is I can say text A seeds dot intersection text B seeds. Okay? So what this is going to do is this is just going to tell me what are all of the seeds in text B that are also in text A. This is much, much faster than that find function because it does one comparison instead of having to go through the entire text running a bunch of finds. So what I'll do is I'll return this. Okay? So I'm just going to return this intersection. So we can go ahead and try this again. So instead, let's just do something like this. We'll say, index 1 is get index test string, and then I'll do index 2 equals get index looking for test string test. Just exactly what I did before. And now I'll compare these indices. Compare index 1 and index 2. And let's print this just to see what the output looks like. Run this, and we can see trin test ring str t space st stri. These are the shared seeds, but you'll notice they're not in a meaningful order. So now if I want to get where do these seeds occur in text B, I'm going to write a separate function that just is something like get seed locations, and then I'll take the index, which will be the index from text B, and these shared seeds. Okay, and I'm just going to call them seeds here. Then all I need to do is I just need to say, we'll make a list comprehension because this is a little bit faster. And I'll say index seed for seed in seeds. So what this will do is this will go into this index, and this will find where these seeds occur. It's really, really simple. So I'll say index seed for seed and seeds. So now I have a list of the seeds. Now I could, if I want to keep track of the seeds themselves, add something like seed, index seed for seed and seeds. Okay, so to actually use this, what I can do, first I need to return this, so I'll get it back. And so now I want to say something like shared seeds equals compare indices, just like that. And then I can print get seed locations, and I'll give it my index 2 because I'm looking for these seeds in text B, and the shared seeds list. And so I'll run this like this. Whoops. And we can see that S12, TST 14, STRI 16, 17, and so on and so forth. So this isn't in order, but it is the results. And so this is exactly what we're looking for, and this is more complex than the find function, but it does operate, at least it will when we're working with very large texts, at a much quicker speed. So now we have several choices to pick from when we're developing our algorithm. We have a find function, and we have this indexing and comparing index function. But for the moment, I think this is a good place to stop, and I hope that I'll see you next time. So for next time, we're going to use the unit test module to test these functions to make sure their output is what we expect, and we'll use cProfile to see how long it takes for them to run, how many calls they're making, and these sorts of things. And we're going to refine these slightly and pick one that's going to work for us as we develop our intertextuality detection algorithm. Okay? Thank you.